We're going to look at two main ideas that sort of go together in this video, and we're going to look at restriction of a function, and we're going to look at what's called implied or maximal domain. So first, looking at restrictions of a function. So consider these here. They're kind of the same, but they're different. They all have the same rule. It's written in function notation: f of x equals x squared, g of x equals x squared, h of x equals x squared. Well, that's all pretty much the same, apart from some superficial stuff. If we look at the graphs of them, however, well, they look different. The first one has no restriction on its domain. So all the possible x values are pretty much in the world of math methods, which is what this video relates to. Anything can be used as an x value. So the domain is unrestricted, all real numbers. So the range will go from 0 up to infinity. So we've got the domain is any real number, and that's listed there. The range, well, it can't go lower than 0, clearly. So 0 inclusive up to infinity non-inclusive. Alright, so the next one too, it's based on the same function, but we've got a restriction on the domain from -1 to 1 inclusive. You could also write that as this interval. And we look at the range. It's got a restriction on it, so it can go down to 0 inclusive. It can go up to whatever the that highest value is. So if you substitute in either 1 or -1 into x squared, you'll get 1 out. So up to and including 1 on the y-axis or the vertical axis. Last one here is anything from 0 upwards, only positive, or in other words non-negative values, which that includes 0. So we've got that restriction on the domain, and so the range would be from 0 up to infinity. So you note the brackets there. Let's have a quick look at some other examples. We see x squared minus 2x plus 8, and basically we've got an unrestricted domain. Okay, x can be any real number. So we can see that if you plotted that, it would produce that graph, and we can see a couple of key points. The turning point there is 1, 7, so that's the lowest point. Cuts the y-axis, the y-intercept is 8, and so basically we can rearrange that. Don't worry about that step there at the moment. It's correct, but that comes with some work we're going to do later in a later unit. Basically, we can see the range is from 7 inclusive, because you can see that there from the graph, up to infinity. It keeps climbing and climbing. So you can see the interval there, 7 of infinity. The next idea, as I said, and the final idea, is implied or maximal domain. And the implied, or in other words, maximal domain of a function is a set of all real numbers for which the rule of the function has meaning. So if there's no given restriction, like we saw in the previous part of the video, we assume that we have an implied domain or a maximal domain. So it's the biggest sensible, meaningful domain that a function can have. So that's what we say the domain is, unless we're given other information. So if we're just given this function, we assume that it's valid for all, the domain is valid for all real numbers. This one here, the biggest domain is not all real numbers, because we only deal with real numbers, and if you try and take the square root of anything less than 0, it has no meaning unless you do a specialist math, and it does. But in this course, it can't go below 0. So we can't, in our course here, we can't do things like that, and a regular calculator won't do that. That's square root of any negative number. Okay, so 0 as low as it goes. It can include 0, and it can, there's no limit to how high it can go. Quick examples here. So what we have to do is we have to state this maximal or implied domain, sketch the graph, which you could use a graphics calculator for, or by hand, and find the corresponding range. So we've got 3 things to do for 3 questions. So the first one here is the square root of 2x minus 5. So basically, we recall from what we just saw that we can't take the square root of a negative number, so the bit under the square root radical sign there, the 2x minus 5, has to be greater than or equal to 0. You can take the square root of 0, but nothing below that. If we solve that little inequality, x would have to be greater than or equal to a 5 on 2. Okay, because 2 times 5 on 2, take 5, is 0. So it has to be no smaller than that. And so that's the lowest end. It can be 5 on 2, but nothing else. And it can go, there's no limit to how high it can go as per that previous example. So the range goes from 0 up to infinity. And the second one there, 1 over 2x minus 5. Again, there is one thing the 2x minus 5 can't equal in this case. 1 over 0 is undefined, so 2x minus 5 cannot equal 0. So notice how really interesting difference there between an inequality and that inequality. Okay, that's greater than or equal to, and that's not equal to. So inequalities are important, and that means x cannot equal 5 over 2. So basically it has what's called a discontinuity there. Okay, the function is not defined when x equals 5 on 2. There's one spot where it's got a discontinuity. It's defined before that and after that. So it has all real numbers are possible for the domain except for 5 on 2. Note that backslash notation, and the range is not defined at y equals 0. So all real numbers excluding 0. Note that nice simple notation there. 4 minus x squared is the last example, and let's have a look. It's defined basically for all x, so its domain, its implied domain would be all real numbers unless we're told otherwise, and we're not, so that's our implied or maximal domain, the biggest one that makes sense. And the function, if you plotted it, would be this upside down parabola, which would keep going, but its turning point is up there at y equals 4. So basically it's unrestricted along the x in both directions. It's unrestricted downwards on the y, but it cannot climb higher than 4. Okay, so you've got the range there. The domain is all real numbers, and the range is from -infinity to 4. So that's the idea of the implied or maximal domain.